Hi, we're going to be learning a little bit of computer science. This is computer science support for the Tracy Unified School District, geometry lesson, and we're going to be looking at fans and how we can use them. We'll use a little bit of math and a little bit of coding to engineer a better fan. Of course, something spinning around like a fan or a windmill is it's nothing surprising in the city of Tracy. It's something that we notice all the time. So students are going to have a lot of fun engineering their own and learning a little bit more about how to gather data and process data. In fact, this unit's computer science is data and analysis. See, there are 5 categories to the California Computer Science Standards. Computer systems, the machines that we use to compute. Algorithms and programming, writing the code we think of in computer science. Networks and the internet, the way that we have computers talk to one another. Data and analysis, because so much of what we use computers for is gathering and processing information and then communicating that information to others. And then lastly, impacts of computing, because we want the students to have the ability to engineer solutions for everyone. So we are focused on several different standards in this unit. Definitely, as far as NGSS, we're going to be looking at all of those engineering standards. For math, our standard is GCO5. Given a geometric figure and a rotation, reflection, or translation, draw the transformed figure using, for example, graph paper, tracing paper, or geometry software. So you might end up drawing your triangle or whatever shape you're going for on construction paper or foam and then cutting it out so that you can make it into the blades of the fan. I went ahead and was showing a side proof for the fact that one blade is another blade translated to another spot. Like on this that Stephanie here at the lab built. Stephanie is constructing the blades of this windmill using both popsicle sticks, which have been cut down, and foam. Your students could use something like construction paper or cardboard. They also could use tape. The idea is that we want to try different geometric shapes and have them catch the wind. Here, the hub is a 3D printed piece that the blades fit into nicely. It doesn't need to be something that's engineered specifically for this. We've built fan blades with bottle tops and CDs and all sorts of different stuff. Students can try out and see what works. So we have our fan blades and we can place them onto a stand. This stand was made out of Legos. And now that it's here, we can gather our data. One of the best parts of this project is that students are going to be gathering data. They're going to be finding numbers and values that represent the science that they're doing. Here you'll notice that we have a tape, a colorful orange tape, added to a fan blade so that we can easily count how many times the blade goes around in 60 seconds. For our computer science standard, we have 912 DA10. Create data visualizations to help others better understand real-world phenomena. Now, there's a couple of ways that we could do that. The first would be to just go ahead and put the data that we gathered into a spreadsheet. Now, the spreadsheet that we're going to be using is called Google Sheets. Google Sheets is an online spreadsheet from Google, which is very much like Excel. Let's take a look. Right here, you'll notice in your lesson, there's a link to a spreadsheet. We went to that spreadsheet and then went to File and Make a Copy, made a copy of that spreadsheet in our own Google Drive. Once we did that, we were able to share it and edit it and add in our data. You'll want to make your own copy and then share that link, maybe in a team, to your students so they can add in their data. Now, creating a data visualization in Google Sheets is not hard. I'm selecting Data, Insert, and Chart. Oh, hey! I'm going to go ahead and close that so we can see. Okay, these are the surface areas between the 3 different fan blades. Okay. Now, notice these don't show up as well, and that's because, well, they'd be so much smaller because the RPM is so much less than the surface area number. Now, this is fine, but let's edit it and think about what other ways could we represent. I could change the chart type. Oh, and there it's giving me previews of what this could look like. Neat. I could also say, you know what, maybe I don't want to show the surface area since it completely hides anything else. So I could say, no more surface area, I'm going to remove it. Oh, hey, now we see RPM and number of blades. Interesting. Now, we don't have to do our chart in Google Sheets. Instead, we could use something called Pyret. Pyret's going to allow us to do some coding. It's an online platform for coding, and it's also a language that we're going to try out. Let's go to code.pyret.org. We're not going to spend a lot of time in Pyret, but I do want you to get a chance to see what it is and try it out today. So, very often the first program that a programmer writes is hello world. So I'm going to write a simple hello world program. I'm going to say print, and then the argument, the information that I'm going to give to the function print, is going to be a string, a series of characters, hello world. All right. I can click the run button to run that code. Oh, there we go. It says hello world. Now we can also do some very simple calculations with Pyret like we would with any other programming language. Let's say I said 3 space plus 4. Oh, that's 7. I can make it more complex. So instead of being 7, we'll get 6. It's very easy to miss that we need a space between our operator and our number. It will error out if I don't. Let's assign this value to a number. I'm going to call this info. So I've stored this value in a variable called info, and I'm going to print my variable. So now when I run this, cool. I can also type something that I want to be immediately evaluated right into this command line here. So I could say print something. And then when I hit enter, it immediately runs. Okay, so we've got a chance to try out Pyret. Let's see how we could use Pyret to make our data visualization. There's a link to this program in your lesson. As our program begins, you'll notice there's all these includes. These are libraries. They give extra abilities beyond the standard language to our program. Next, we open up a spreadsheet. Any Google file, any Google Doc, has a code in its URL. We're going to use that code to tell our program where to go. So I cut this right here, and I pasted it into here. Now it's able to open up that document and add all of that information into a table. I'm going to run my program, and don't be alarmed, nothing immediately happens, or it doesn't seem to happen. But it has taken all that information, and it's given me this code right here that I can use. So I'm going to say, I want to copy that, and then I'm going to paste it. Let's try it out. I'm going to hit enter. Neat! There is my data represented so we can see it. Okay, so students will get a chance to engineer, to look at data, to do a little bit of coding. There's so much going on in this lesson. I hope your students have a lot of fun with it. There is references or examples of code in our Sway, and there's also some videos showing how all of this cool stuff here got made. Okay, I hope you have a ton of fun. Bye.